Hi everyone! Welcome back to integralcalc.com. Today we're going to be doing another example of how to take the cross product of two component vectors. Our vectors in this case are in component form, and we've been given a equals I minus j plus 3k and b equals negative 2i plus 3j plus k. So when we're given vectors in component form, the only formula we really need to remember is the one here, which tells us that when we break these component vectors, when we create a third order determinant matrix and then break it into second order determinants, that we're going to be using this positive negative pattern here to decide the sign, positive or negative, of our second order determinants. So you'll see how that looks when we get to the next step. So the first thing that we're going to do when we've been given these component form vectors is to create a third order determinant matrix here, which just means that we've got a 3 by 3 matrix. And we're always going to put I, j, and k in that order in the first row of the matrix. And then for the second and third rows, we're going to take the coefficients from our original vectors a and b. Sometimes you're given like a point with direction numbers in your vector, and you're just given 1, -1, and 3. In this case, all we have to do is look at the coefficients here on A. So you see that the coefficient on I is 1, it's implied, which is why it's invisible. We have a -1 on the J, because it's a negative here, and then a 3 as the coefficient on our variable K. So that means that our direction numbers for A are 1, -1, and 3. So A always goes in the first row underneath I, j, and k, and we just take those coefficients and put them in order right underneath there. And then we find the coefficients in B and make that our third row. So in this case we have -2, 3, and 1. So we put down here -2, 3, and 1. And that's how we build our third order determinant matrix. And then from there, we're going to take it and break it apart into second order determinant pieces so that we can simplify and solve for the cross product. So here's what that's going to look like. The first thing that we're going to do, you'll notice that we have I, j, and k multiplied by these second order determinant matrices. So we're always going to have that. And the way, notice that I is positive, j is negative, and k is positive. Well, the reason that we have that is because I here in our third order determinant matrix is in the upper left hand corner, right? Well, if we're following our formula, we have a positive here in that upper left hand corner, which is why I is positive. J is negative because it's in this second spot right here, and our formula tells us that that spot is supposed to be negative. So we have a -j and then a positive k, because k here corresponds to this positive sign here. And it doesn't matter how big your original matrix is. So if you're dealing with cross product and you build a 2 by 2 matrix, a 3 by 3 matrix, a 7 by 7 matrix, it doesn't matter. You're always going to start with a positive sign in the upper left hand corner and then build like a checkerboard pattern, alternating positive, negative, positive, negative, and then starting the second row with negative, positive, negative, positive. So you build that checkerboard pattern, and then that's how you assign to I, j, and k here. So just keep that in mind. And then as far as these second order determinant matrices go, the way that we build them is the following. So the one here that's multiplied by I, what we do is we look at our third order determinant matrix, the original one that we built here, and we're going to, I is in this first position here. We're going to ignore everything in the same column and the same row as I. So we're going to ignore j and k because they're in the same row with I, and we're also going to ignore 1 and -2 right here because they're in the same column with I. So we're ignoring this column and we're ignoring this row, which means that we take everything that's left and make that our new matrix that we multiply by I. And everything that's left in that case is -1, 3, 3, and 1, which is why we put the -1, 3, 3, and 1 here. And they're always going to translate in the exact same position. So you're just going to take that whole block and move it straight over. You're not mixing up the numbers in any way. So we'll just look at what we multiplied here by j, right? Remember that we're ignoring everything in the same row as j, so we ignore I, j, and k here, ignoring the row, and then we're also going to ignore the column. So we ignore -1 and 3 because they're in the same column as j, which means we're left with 1, 3, -2, and 1, and we're going to take that 1, 3, -2, and 1 and move it straight over, and we get that 1, 3, -2, and 1 multiplied by j. Again, not mixing up the numbers. We do the same thing with k. So once we've done that, we can go ahead and start simplifying to solve for the cross product. And the way that we do that, notice we keep I, j, and k exactly as they are. We've got positive I, negative j, and positive k here. And then we get these numbers by looking at the matrix that's multiplied here by I. What we're going to do is multiply the upper left number by the bottom right number. So -1 times 1 is -1. So we get -1 here in this first spot. That's how we get that number. We're always going to subtract in the middle. You see we have subtraction here, and subtraction here. You're always going to subtract. And we get the second number, in this case 9, by multiplying the bottom left number with the upper right number. So 3 times 3 is 9, which is why we get the 9 here. So again, it's this diagonal pattern, -1 times 1 here, minus 3 times 3 this way. And we're going to do the same thing with j. So 1 times 1 here gives us 1 in this spot. We always subtract, and then we do -2 times 3 here, which gives us a -6, so we subtract that -6 there. Don't forget to, include both negatives. This is always going to be subtraction, and you might have a negative sign and get that double negative. So that's how we build this step here, and then our final step is just simplification. We're going to obviously simplify. -1 minus 9 is -10. 1 minus a -6 is going to be 1 plus 6, which gives us 7. And then 3 minus 2 on the k is 1. And then I'll go ahead and simplify one more step and make these 3 coefficients on our I, j, and k for simplicity. So we're going to end up with -10i minus 7j plus k. And once we've done that, to find our cross product vector, all we do is take the coefficients on I, j, and k in this new vector and put them into this point form here. So we're going to have -10, -7, and 1 pulling from the -10, -7, and 1 coefficients here on this vector. This is the component form of the vector, just like we had up here in our original problem. And then this is just the point itself. So -10, -7, 1 is our cross product for these two vectors in component form. So I hope that helped you guys, and I'll see you in the next video.